To begin this video on conversions, we're going to talk about converting units, and this is usually pretty straightforward. So if I ask you how many inches are in a foot, you can pretty easily tell me there are 12 inches in 1 foot. And in keeping with that, if I ask you how many inches are in 4 feet, or to convert 4 feet into inches, well, you're going to say there's 12 inches in a foot. 4 feet, 4 times 12, 48 inches. So if I'm converting 4 feet into inches, there's 48 inches. Now let's put this in math terms so that we can prepare to do some more complicated problems on the next few slides. When I'm doing conversions in math, I always want to have a fraction. So if I'm starting with 4 feet, I need to start with a fraction. All I need to do, put it over 1. Now 4 feet is a fraction. Next, I need to figure out something called a conversion factor. Now, a conversion factor is a fraction that expresses one unit in equivalent terms as another unit. So, for instance, let's say we have 12 inches per 1 foot. 12 inches and 1 foot is a conversion factor. These two things, 12 inches and 1 foot, are the same quantity. So this is expressing inches in terms of 1 foot. We can also write this conversion factor as 1 foot per 12 inches. Okay? The conversion factor we use, this one or this one, is dependent upon what our original fraction is. And the reason is because we want to make sure our units cancel. So if I have feet on the top, I am going to pick the conversion factor that has feet on the bottom. Because in fractions, if we have something on the top and something on the bottom, we can cancel. Just to remind us of these fraction rules, I'm going to do a little side problem. Let's say I'm multiplying 3/4 by 1/3. Well, I have a 3 on the top here and a 3 on the bottom here. So I can cancel them out when I multiply across. 1 and 1. So when I multiply across, I get 1 over 4. And just to double check our math, if we were to do 3/4 times 1/3 without doing this canceling, well, we multiply across the top and bottom when we're multiplying fractions. So we would get 3 over 12. This fraction simplifies down to 1/4. So we use these same rules to cancel out units. If you have a unit on the top and a unit on the bottom, those units will cancel. So back to our previous problem. I have 4 feet on the top and 1 on the bottom. If 4 feet is on the top of my fraction, I need to have feet on the bottom so that my feet units will cancel. So this is the conversion factor that I'm going to use. This one over here would not work because feet is on the top and not the bottom, so my units would not cancel. So 12 inches over 1 foot. And now before we do out the multiplication, it's always a good idea to check your units to make sure you have what you're looking for. Here, feet canceled, so I'm left with inches on the top, and on the bottom, feet canceled, so I have no units on the bottom. So let's multiply across. I get 4 times 12 is 48 inches over 1. 4 feet is 48 inches. I know you all did that much more simply when we originally laid out the problem, but we just want to make sure that you see this conversion factor in simple forms before we take it to the next level, which will be converting rates. So this is an example of this same problem using a conversion factor. Now we're going to talk about converting rates. So if I give you 80 miles per hour as our original rate, and a rate is simply a fraction that has 2 different units in it. So 80 miles per hour, 5 cookies per minute, all of those are rates. They have different units on the top and different units on the bottom. And so let's say we're working with 80 miles per hour and I want to convert that to feet per minute. Okay. Well, I need to know 2 pieces of information. I need to know how many feet are in a mile and how many minutes are in an hour. So We know that there's 60 minutes in 1 hour, and we know that there are 5,280 feet per 1 mile. So these are the two pieces of information up here that will help us create our conversion factors. So 80 miles over 1 hour. Now I need to convert the 80 miles and I need to convert the 1 hour. Doesn't matter which one we convert first. So just for sake of argument, let's convert 80 miles first. So if I have miles on the top, I need to have miles on the bottom. That's how I get them to cancel out. So how can I write this so that there are miles on the bottom? Well, 5,280 feet over 1 mile. Miles cancel, good to go. Now let's look at hours. I have hours on the bottom and I need hours on the top. So I use this piece of information here. 1 hour is 60 minutes, okay? Hours on the bottom, hours on the top cancel out. And now again, before we do our math, we want to check our units. Units canceled, feet, unit canceled, which means on the top, I have feet as my unit. Here, units canceled, units cancels, minutes. So on the bottom, my units left are minutes. Feet per minute is what the problem asked me for. Feet per minute is what I have here. Now, all I need to do, now that I've checked my units, is multiply across. So 80 times 5,280 feet times 1 is 422,400 feet on the top. Now on the bottom, I have 1 times 60 is 60. Now, I have an answer, but I always want to make sure that I have fully simplified fractions. So in order to do that, I divide the numerator by the denominator. So I'm dividing 4,220,400 by 60. And I'm going to get 7,040 feet per 1 minute. And there's my final answer. When we're using conversion factors, it's important to remember that we're always using multiplication and we're always setting up our conversion factors so that the units cancel on the top and the bottom based on what the original problem was and what we are looking for in the end of the original problem. So the key here is really reading the problems that you are given and checking your units. Now let's try a different example. Here I have 500 meters per 1 minute, and I'm looking to convert that to kilometers per hour. So 500 meters per 1 minute. And in order to do this, I need to know how many minutes per hour and how many meters per kilometer. So I know there's 60 minutes in 1 hour, and I know that there are 1,000 meters in 1 kilometer. Okay? Kilometer, kilo means 1,000. So a kilometer, there's 1,000 meters per 1 kilometer. So now, again, doesn't matter which one we tackle first. We can either tackle the meters or the minutes first because we tackled time previously first in the last problem. We're going to tackle the meters first. I have meters on the top, which means I need meters on the bottom. Looking at this piece of information, I know there's 1,000 meters in 1 kilometer. So I can set up my conversion factor. My meters are going to cancel. Next, we'll look at the minutes. I know minutes are on the bottom, which means I need to put minutes on the top. So 60 minutes on the top, 1 hour on the bottom. Minutes are going to cancel out. Okay? Now let's check our problem to make sure we have the right units. Well, on the top, canceled units, kilometers, canceled units. So I have kilometers on the top and on the bottom, canceled units, and hours. So I have hours on the bottom. Looking at my original question, kilometers per hour is what I would like my answer to be. That is what I have. So we are good to do our multiplication. And just with any fraction problem, when we're multiplying fractions, we multiply everything on the top. So 500 times 60, 5 times 6 is 30, and then you just add your zeros. So we have 30,000 kilometers. And on the bottom, 1 times 1,000 times 1 is 1,000 hours. So here we have 30,000 kilometers per 1 hour. And again, we always simplify our fraction. Luckily, it's easy to do that here because we can just cancel out our zeros. And we're left with 30 kilometers per 1 hour. So 500 meters per 1 minute is equal to 30 kilometers per hour. Now this example is going to be a little more complicated because we're going to need 3 different conversion factors. And the key with conversion factors is you use as many as you need. The process is the same. You continue to set it up to make sure your units cancel, and you use as many conversion factors as you need to get to the answer desired. So here we have 100 miles per 1 hour, and we're looking to know how many feet per second. So I know there's 5,280 feet per 1 mile. I also know that there are 60 minutes in 1 hour. The problem is I'm not looking for minutes. I need seconds. So I also know that there's 60 seconds per 1 minute. So in this case, we're going to have 3 different conversion factors. So starting with our original problem, again, it doesn't matter what you do first. Let's start with hours. So I have hours on the bottom of my fraction. I need hours on the top so that my units will cancel. Looking up here, we've got 60 minutes per 1 hour. Again, though, we're not looking for minutes. So now we need to convert those minutes per second. Oops, this should have been 1 minute. There we go. Now we need to convert those minutes to seconds. So minutes are on the bottom. I need to have minutes on the top. I know there are 60 seconds per 1 minute. Okay. Minutes cancel, minutes cancel. I have seconds is so far my unit on the bottom. Okay, that is what I'm looking for at the top, so that's good. Now that I've dealt with my time conversion, I'm going to look at my distance conversion. I have miles on the top, which means I need miles on the bottom. 1 mile, 5,280 feet. Okay. I should be good to go. I cancel my miles out. Now I should be good to do my multiplication, but let's double check. Always double check your units before you do out the multiplication, because there's no point in doing out the multiplication work if your units are messed up. So on the top, I have miles canceled, hours canceled, minutes canceled. So those units are all gone. My units left on the top, the only units left are feet, good to go. On the bottom, canceled, canceled, seconds, and canceled. So the only units on the bottom that have not been canceled are seconds. Again, we look at what the problem was looking for, feet per second. That's what we have. We're good to do out the multiplication. And just because I'm running out of room, I'm going to bring this down here. So we multiply out 100 times 1 times 1 times 5,280. Well, the nice thing about 100 is all you have to do is add 2 zeros. So we get 528,000 feet on the top. 1 times 60 times 60 times 1. Well, 6 times 6 is 36, and then you just add 2 zeros, and we've got seconds on the bottom. So we get 528,000 feet over 3,600 seconds, and this is not a fully simplified fraction. So we cancel our zeros. We get 5,280 feet over 36. Both of these numbers are divisible by 12, so we get 440 feet over 3 seconds. Now, this is a fully simplified fraction. However, that is not normally what your teacher is looking for. Usually what we're looking for here is something called a unit rate. And a unit rate is when we have 1 in the denominator of the fraction. And all we need to do to get a unit rate is divide the numerator by the denominator. So if we do 440 divided by 3, we get 146.6 repeating feet per 1 second. This unit rate is usually what the problem is asking you for. And the reason we use unit rates is because it's an easier thing to compare. If we are all talking about miles per 1 hour as the speed limit, we can compare our relative speeds pretty simply. If I'm going 30 miles in 6 minutes and you're going 70 miles in 4 minutes, it's hard to figure out what that means relatively. Whereas if we each have 1 in the denominator of our fraction, it makes a little more sense in comparison wise. And you'll also notice that the top of this fraction has a decimal. Normally, you are not allowed to have decimals in fractions. This is the exception to the rule, is when you're using unit rates. So these were a few examples. I hope this helps your process with conversions. If you have any questions, feel free to email me. The next slide, I'll give you 2 problems for you to do. So when you get to because this is a video, when I switch slides, simply pause the video, you do the problems on your own, and then play the video and the answers will pop up so you'll be able to check your answers. Here are 2 practice problems to do on your own. Simply pause the video now and replay when you've finished the problem so that you can check your answer.